Hi, everyone. My name is Daniel Moyer. I'm one of the sales support trainers here at Briggs and Stratton Energy Solutions. Today, what we're going to be talking about is an intro to the 6.6 battery backup system. And you notice how I said battery backup system. So when I first got it started in this industry, the idea that we would install batteries without solar, without a generator, was a little foreign to me and a little confusing. But I started to realize that there is opportunities in installing just a battery backup system. Of course, the energy is only going to last as long as there's juice in the batteries. But given that most people's outages aren't as long as a lot of people realize, it can serve as a great function to providing resiliency. Of course, if you add solar, if you add a generator, you can essentially off-grid the home and live off-grid independence. We'll talk a little bit about that today. Couple housekeeping items. The chat is disabled, but the Q&A is open, so please put your questions and answers and comments in there. Not your answers. We'll try. If you have an answer to a question, I'd love to see it. Also, keep in mind that this class is not NABCEP accredited, so we're going to keep it kind of short today. And keep in mind that a lot of our other future courses will be NABCEP accredited. So let's go ahead and jump into it. Really, at the heart of all of these systems is the hybrid inverter. Our batteries are able to pair with a lot of different inverters. One inverter we've really had great success with is that Sol-Ark that you see in the middle of the screen. Keep in mind with the battery backup system, right, we're not really ever going to be backfeeding to the grid. You see kind of this bi-directional arrow. And in a lot of cases, even if you do add solar, the solar production in a lot of states is not really able to be sent back to the grid. Well, you can, but you're really going to see very little value out of it. So as we kind of mature in our industry, we're noticing that this bidirectional grid isn't as common as we might have seen in the past. There is a lot of states that still do have favorable interconnection policies that allow energy to be sent back to the grid, and you get that one-to-one credit. But we're not seeing that here in California. There was some recent changes to some of the laws that they were going to essentially kick everybody off the grandfathered in from the NEM 2.0, that favorable net metering, where people had that 20-year grandfathered. That has been not passed. And so we are still seeing people that are on NEM 2.0 able to stay on that. When we look at, though, adding a generator is really key to providing that extra level of resiliency. So there may be situations where the homeowner can't do solar. Maybe there's trees, or they just don't have the ability to put on solar. Maybe they don't want the look of it. Personally, I think solar panels look great, but they can definitely add a generator and have that generator be controlled by our 2-wire signal to start based on the state of charge of the battery, start up that generator and charge up the batteries, and then shut that generator off. Again, having the inverter is a key piece of the puzzle there, and I'm really excited to see all of these hybrid inverters coming onto the market. It used to be we'd have all these different charge controllers and automatic generator start and trimetric battery meters, all different parts and pieces. And to see these companies coming out with hybrid inverters, putting all those parts and pieces into one, is really exciting. Another thing that's exciting in the market is that these hybrid inverters are becoming more powerful, not only on their continuous output, but also their surge capabilities. With the advent of our batteries that are now easier and quicker to install, that the price of the batteries have come down, we're moving away from that kind of partial home backup model that you've seen historically and moving more towards whole home backup. One of the key features of a lot of these hybrid inverters is that 200 amp pass-through. So the idea that you can take grid, all 200 amps, most homes have a 200 amp service, bring 200 amps in, 200 amps right back down to the load center, back up the entire home. If you do have a 400 amp service, you can always add multiple inverters to give you that capability. One thing to keep in mind is that when we're doing battery backup systems, the amount of backup is really going to depend on the home's loads, right? The time that they're going to have that backup. A lot of these hybrid inverters, all of them, I would say, and even our EnergyTrak, our internal app, provides a notification that the grid has gone down and then gives you a backup timer or an estimated amount of time that you have remaining in your battery based on your current loads. A lot of homeowners will start to turn off unnecessary items so that they don't start a laundry cycle when you're on an off-grid situation, be able to extend that out. But when we are able to combine them with a generator, we can offer some of those luxury items. And using a generator to charge up a battery system has always been part of the mix when we're talking about off-grid. I'm noticing that more and more often on-grid systems as well. So when we start up a generator, like I mentioned, based on the state of charge of the battery, not only will the generator start to charge the batteries, but it will also take over the loads. And if you look at some of the fuel consumption profiles in some of these generators, especially ours, the generators actually become more efficient when they start to get at higher load levels. Keep in mind, most people that have standby generators, they're 18, 22, 26K generator, they're not running at 26 or 22K when they're running. They're probably just providing maybe 2,000 or 3,000 watts to power the lights and the smaller home loads. We oversize those generators so that they're able to start large motor loads like a well pump or perhaps an air conditioner. Well, if we're able to start up that generator using an energy storage system, we can charge up the batteries quickly, running a generator, not pedal to the metal, but maybe at an 80% load, run the generator for perhaps 2 hours, charge up that battery, and then shut it off. We're saving fuel, not only from the runtime, but also running it at a more fuel efficient point, saving the noise and the maintenance that come with running that generator. Our generators are approved for what's known as non-emergency use. So what that means really is that if you have an off-grid home that has an energy storage system, another prime source of power, we do have warranties that cover our generators in those applications. Those are included on 18, 22, and 26 as well. We are really excited about our 6.6 stacking battery, but we still are offering our Phi and SimpliPhi batteries, and that's what you see down in the bottom right-hand corner. One thing that makes these batteries really desirable is that they're able to be kind of put into the same place, the same form factor that a lot of lead acid batteries would fit. The Phi battery, the one that has non-communications available, comes in either 24 or 48 volts. 24 volt is a great older system, older architecture. And if you don't want to replace all the equipment, that old trace inverter, the old trimetrics, you can use our 24 volt Phi batteries. The Phi also doesn't have closed loop communications. Almost all the batteries on the market now have that. We're still making one that doesn't have it because there's a lot of older systems out there where the inverter, the charge controller can't leverage closed loop communications. So why make a more expensive battery management system? As long as you get the bulk, the float, the absorb voltages programmed correctly in that other older pieces of equipment, you can absolutely use our Phi batteries. We do make a version of the Phi called the SimpliPhi that does come with closed loop communications. And that's what you see down in the right-hand corner or the right-hand side of your screen. Our access cabinet. This is a great option for somebody that can't install a battery on the side of the house, in the garage. This is a standalone cabinet that can be positioned anywhere on the property, really, and then be able to put the batteries on the bottom and the inverter on the top. What we get a lot of questions is, can we put a Sol-Ark 15K in here? And you're looking at a Sol-Ark 12K there. Unfortunately, we can't. The heat generated by a Sol-Ark 15K, especially when it's processing a lot of solar, just doesn't allow enough ventilation in that cabinet. So keep in mind, we still offer these. These do come with all of the UL certifications, the 9540 that you would expect in all of our systems. Additionally, we can take out that inverter and put in just an entire stack of batteries. We call that the Boss 12. We also have a Boss 6 cabinet, which is kind of a half-size cabinet that can be populated with the Phi or the SimpliPhi batteries. Again, what I talked about earlier is that battery backup systems, which is a little bit unique. I think they're great for homeowners that have outages, maybe they live kind of more in the suburbs or more in the city where they're not expecting to be the ones at the last end of the line to get their power back on. Most of their outages are measured in hours, not days. And there's also a lot of opportunities when there's HOAs that prohibit the use of a generator. A lot of homeowners now in California especially don't have natural gas lines coming to their house. They're not able to install a propane tank. So they're the all electric homes that we're starting to see come onto the market. Having a battery backup system is going to provide them that backup opportunities without the use of a generator. Of course, they can always add solar in the future, and I would expect a lot of people that have battery backup systems will want to add solar in the future as well. They can always expand that. You know, we always say in the market that we don't offer there's no traditional maintenance with solar or battery backup systems. And I'd love to see in the comments, the Q&A, if somebody out here who's an installer still offers a maintenance plan for their battery and solar systems. The installer always worked up at, we would come back yearly, we could clean the solar panels, we could do an off-grid test, we could torque down those breakers, we could maybe even do firmware updates and checks. So having that maintenance package is still an opportunity. A lot of the generator dealers out there, you know, a lot of their income is based on these maintenance packages. You sign them up for an annual subscription and you come out and do the oil changes, the AVR test, change out the starting battery in the generator. There's still opportunities out there as well. One thing I want to bring up on this talk, and I think it's probably on the minds of a lot of people on this call, is that 30% tax credit that's in jeopardy right now. And we'll bring that up here in a second. Seamless and nearly instantaneous backup transfer, I think, is a key. A lot of the generators on the market usually have a 30 to 1 minute kind of transfer time, right? The grid goes out, everything's dark, the generator starts up, it has to, you know, kind of get up to speed, and then it will send a signal to transfer to the transfer switch. By that time, all of the clocks have reset in the home, the internet router's probably rebooting. By having that really quick millisecond transfer time, a lot of homeowners like that, and that's a great selling feature of these battery backup systems compared to the generators. Fuel usage and fuel concern. I know a lot of portable generators, that's kind of a common way. You got to keep gas around. And unless you're putting stable in that gas, a lot of times it just goes bad on you. Another thing that battery backup systems can use without solar can also be time of use arbitrage, where in a lot of places around the country, during certain times of the day, 4 to 9, 5 to 10, electricity is more expensive. We can charge up those batteries when electricity is cheap, and then discharge that battery to home loads when it's expensive, saving the homeowner money. Another big opportunity is these demand response programs where the utility can take control of your energy storage system and then discharge the battery maybe to home loads or maybe even back to grid. Why would a homeowner let the utility do that? Well, they're going to get financially compensated. There's different models out there. Sometimes people just get a flat payout every year to be part of the program. Sometimes it's based on the amount of watts or kilowatt hours that the system's capable of handling. It's a really unique situation where these distributed energy resources, batteries on people's homes, can be part of the solution to the stability of the grid. Again, that's without solar. Going a little bit back to the 30% tax credit, and please, anybody on here, let me know in the Q&A if you're taking any action. SEIA, the Solar Energy Industry Association, has made the plea out there to get your voice heard. One of the things they can do is they started the Solar Powers America. And if you are getting emails from SEIA, please take a look at those. You can fill out this form. Everybody on this call is going to get not only a copy of this slide deck, but a recording. And this specific page will have a link that goes to this form. Let's take a look a little bit about our kind of flagship product, which is our 6.6 stacking battery. On the left there, you see a stack of 3 6.6 modules. That brings it up to a total of just under 20 kilowatt hours. That's intentional to meet the NFPA 55 building and fire code standards. Every system is going to need the following components. You're going to have a controller on the top. You're going to have at least one battery module, and you're going to have a base. We either offer a floor base or a wall base, and I think it's really nice to have an opportunity to install the battery on the wall. We as installers, a lot of times we install a system, we run back out to our truck, and we're gone on to the next job. But the homeowner is going to have to look at this system for a decade or more. And having a good looking battery that's up off the ground is really nice for a homeowner, especially some of the garages that I've seen with a lot of junk in the garage. So the base not only provides the structure for the batteries to rest on, but it also has a loop back for the closed loop communications. So there's little pins in there that send the signal back up to the inverter, to the EnergyTrak, so we know where the closed loop communications end. Every system is going to have an inverter, a hybrid inverter. We also have the EnergyTrak. EnergyTrak is our monitoring platform. It allows you to have more granular, detailed information on the batteries. So that system is a subscription-free app, and that will then communicate and have not only the ability for the firmware updates to take place, that detailed level, but also you as the installer, if you ever have a problem with that, you can allow our tech support team here at Briggs and Stratton Energy Solutions to remote in and help you diagnose any problems that you may have. A couple little things that make us special is I still like that we have status LEDs on the top. A lot of batteries don't have any sort of indication of the state of charge of the batteries. Also, our ability to rapidly stack. There's a lot of stacking batteries out on the market, and not all of them truly stack in the sense that they physically stack, but there's still, if you open up the side cover, still communication and power conductors stacking between the two. With our rapid stack connector, not only does the power, but also the communication stack together, making that install really quick. And I know you installers on this call, a lot of our cost of our systems comes out of the install, the labor, not necessarily the products. All of the batteries stacked together with these alignment tabs, and those all have little screws that hold it together. Again, Sol-Ark is one of our preferred inverters, but there's a lot of other inverters coming to the market as well. Indoor or outdoor rated, so we can put these outside. I will say that anytime we're doing these in some colder climates, we want to be careful. We do have ambient temperature rating down to 14 degrees Fahrenheit without heaters. And we do have those Phi and SimpliPhi batteries that do have heating options in case you're in really cold environments. I like the idea of being able to install these without heaters. Keep in mind, heaters are kind of a parasitic load on the battery, and a lot of them draw more watts than you might think, 200 watts, and they're kind of creating hot spots on the batteries. So being able to achieve a lower ambient temperature rating without the need of heaters, I think is a big win for us as well. Another thing that we really excel at is our warranty, a 10-year warranty with unlimited cycles at 100% depth of discharge with no throughput clause. Some of our competitors might say, well, you got a 10-year warranty, but if it's at a certain depth of discharge, a certain number of cycles, or a certain amount of energy in and energy out, whichever comes first, your warranty is up. That being said, we do expect 6,000 cycles from our 6.6 battery, even at 100% depth of discharge. I know in our good old lead acid battery days, we would always want to limit the depth of discharge to 50 or maybe even 80% depth of discharge to extend the life of the battery. What you really notice in some of these lithium ion batteries, specifically the lithium iron phosphate batteries that we're using here, it's the rate at which you charge or discharge the battery that dictates the life of the battery. At the end of that 10 years, we warranty 75% retained energy capacity in our batteries. I will also mention that our SimpliPhi battery comes with a 15-year warranty, same unlimited clauses on that. We used to talk a lot about lithium iron phosphate being a safer chemistry, longer lasting, and a lot of the competition has moved over to lithium iron phosphate. But I would also say that the chemistry alone is not the deciding factor on the safety profile of a battery. In fact, we have a sister division at Briggs and Stratton that creates battery packs for golf carts, for zero-turn mowers, for lawn equipment, and they leverage the cobalt-based chemistries. Why? Because it's desirable in those applications. It can operate at higher ambient temperatures, it can discharge quicker, and it's more energy dense, it's lighter. So really what goes into making a safe battery isn't just its chemistry, it's its battery management system, the design of the case, the design of the cell packs. So keep in mind that there is applications for both cobalt-based chemistries and lithium iron phosphate. For us, for battery backup sides, we're really more focused on cycle life and not so much worried about energy density because we're not moving it around or driving around in a golf cart with it as well. Taking a look at one of our training walls, and this was an opportunity that Nathan Heston and I put together. We got our battery on the left there. Coming out of the battery, we use some flex. I'm not always the biggest fan of flex or liquid tight, but we come down here into our trough, and then we kind of stub up into the Sol-Ark. I notice on a lot of people on the West Coast, and put this into the Q&A if you notice this as well, that we have a lot of what's known as meter main distribution combos where we got a meter, grid's coming in, we got our main breaker, and then in this section would be a bunch of breakers feeding the house. On the East Coast, and the Midwest perhaps, you guys have these things called basements. And what I've noticed a lot is you'll usually have a meter, a disconnect, and then down in the basement, you have your distribution. That makes it really easy for you to intercept the 200 amp conductors that bring into the Sol-Ark and then bring right back out. Out here on the West Coast, you can't really intercept it just as easy. You can't really come up in here and intercept and then kind of tap back over because you would void the UL listing of that panel. So there's a little bit different challenges. There's other opportunities. We can do lug. We can lug off sometimes. We can also have some larger breakers in here that we're pulling it over. But that we intentionally did it this way to bring it over. Keep in mind that whether you do it with the 200 amp pass-through, that's not always necessary. I've seen homes that have a lot of gas appliances, gas furnace, gas stove, gas dryer, can back up a system with less than a 200 amp pass-through. Keep those Q&As coming. We got one right now here. Ken's asking 6,000 or 4,500 cycles at 100% discharge. Slide seems to indicate 4,500. So let's just go back really quick. Whether you're at 100% depth of discharge, either way, you're going to get on 4,500 cycles. That's at a 0.75 C. So that's like maybe you discharge the battery in about an hour and 15 minutes. You could expect about 4,500 cycles. At a 0.5 C, that's a C over 2. So you're discharging the battery in about 2 hours. So you get more cycles if you slow down the charge and the discharge rate. Most people aren't really going to discharge their batteries in an hour and 15 minutes or even in 2 hours. So keep in mind that that's the difference. Whether you're at 100% depth of discharge, it doesn't matter. It's more the rate at charge and discharge as well. So maybe why choose us over some of our competition? We're able to be DC coupled. We're able to bring in DC solar right off the roof, feed it into charge controllers, and then charge up the battery. We can also accept an AC coupled solar for those retrofits. That's a really key advantage that we're able to bring that in. If we only had AC coupling, we'd be dealing with the inversion losses, and also the bottleneck would be the inverter. So we might get some inverter clipping as well. Really excellent opportunities to bring in generators. By being DC coupled, we're able to scale the energy and power separately. And I'll show some examples. What I mean by that is that you could have a single Sol-Ark 15K with one stack of 3 6.6 batteries. That stack that you see on the right is capable of discharging at 14,000 watts, whereas that Sol-Ark is able to discharge the battery at 12,000. So we're able to match that, but we could add additional battery stacks without having to add additional inverters, and vice versa. We could absolutely add some extra inverters as well if somebody needs more power and not necessarily energy as well. I really like our tech support team. They're not only very well versed on our batteries, but also Sol-Ark and other inverters. So keeping that, a lot of times I'll see is that you get the blame game where somebody says it's the Sol-Ark, it's not the batteries, and then Sol-Ark, will say it's the batteries, it's not our Sol-Ark. Where we don't play those games in a lot of ways. We're there to be the end-to-end support, whether you got a problem with the inverter or the battery as well. Additionally, we have very short lead times, which I think is going to be a big deal, especially if that 30% tax credit goes away. We're going to see a huge rush on people trying to get their systems installed before the 30% tax credit goes away. Same thing happened on the net metering side in California, where everybody was under the deadline to get the systems. We have these systems in stock and ready to ship to get you before that deadline is up. Talked a little bit already about how we can bring in AC coupled solar. So what are we looking at? A couple of those good old solar edge inverters, and we're bringing down our DC off of the roof. The optimizers are up there, and we can turn that DC into AC. We can feed the AC into this little combiner panel, and then we're combining up those two solar feeds and then feeding it into the gen port, or we could also feed it onto the load port of the Sol-Ark. And we could still add additional DC coupled solar if we wanted to on those MPPTs. I really like the little concrete pads that they installed here, and we got two stacks right here. So keep in mind, it doesn't always have to be a 3-stack as well. Another great advantage of Sol-Ark is their smart load output. So I imagine in this system that they did pull in the AC coupled solar onto the load center, and then that freed up their gen port to do smart load output. And so always when I would talk about my off-grid systems with homeowners, I said, look, if your batteries are full and the sun is still shining by noon, go ahead and start to do laundry. Go ahead and start to do things, because once the batteries are full and the loads are satisfied, that solar isn't going anywhere. Now, with the smart load outputs, we can automatically turn on those loads and be able to power something, just like this EV charger you see right there as well. John's asking, please ask R&D to get a pre-scored knockout on the side of the control unit where the cables exist. A good news, John, we actually have already made that update. I'm going to go back a slide just to show you what we mean here. That right here, you can see that this is where the conduit's coming out, and you can see that they had to punch that out, get the old punch kit out of the van. What we've recently done, and all new batteries are shipping with this, is that's already pre-knocked out. The inner plate is already pre-punched out to 2 inches, and this outer plate, which is just kind of a vanity cover, is notched. So you're no longer having to get those punch kits out. It's already pre-knocked out for 2 inches. And I would say that that's one of the advantages. As Briggs and Stratton is an American company, we do things to the design of our batteries that make it appropriate for the North American market. I see a lot of competition that's not designed. They'll have cable glands. Well, we don't really use cable glands out here in the North American market. We do conduit. And so we make these things easy to do the conduit runs as well. Let's see, Zen's asking, what is your typical investment payback period? That's a hard question, and what I'll do is say is that if anybody hasn't done this before, is Open Solar or Aurora Solar or Energy Sage. A lot of these solar proposal programs can model the payback on a lot of these systems. So and one of the more accurate ways to model the payback period would be for you to upload the interval data from the homeowner's utility company, because everybody's load profile is a little bit different. If you say you got a retired couple that lives at home and does most of their electrical consumption during the home when the sun is up, they're not really going to need a big battery to store energy during the day to get them through night. If you got somebody like me who's at work or the kids are at school and you come home at night, you're going to have a larger battery, right, to ride through, especially if you can't feed that back to grid. The investment period might be different if you're allowed to feed back to grid and you get that one-to-one credit. The payback period might be different based on the solar insulation availability. Do you got a lot of trees shading your panels, or do you got a great south-facing roof? Time of use. So it's a hard question, but typically what we like to see is anywhere from a 7 to 12-year payback period. And if that 30% tax credit goes away, that payback period is going to go up. Off-grid, we talked about this, but absolutely you can do off-grid with our energy storage systems. They are warranted for that. With the generator having the non-emergency certification, as long as it's paired up with another energy source like a battery backup system, you can achieve that warranty. This is a system of, I wish that was my house on the right-hand side, but this is a great system where we have on the left seat, you can see the two Sol-Ark inverters and then the 4 stacks of batteries. So we have 80, we're looking at 80 kilowatt hours of storage here, and then 2 Sol-Ark inverters. Keep in mind when we're doing this that these 2 batteries don't feed this Sol-Ark, and these 2 batteries don't feed this Sol-Ark. You have to combine the entire battery bank, all 4 stacks, into one, and that's what this midnight solar combiner is right here. And then separate that off and feed up to the Sol-Arks. Same thing applies with the grid input, which there is no grid in this example, but same thing with the load output. This is that great example I was talking about where we can scale energy and power separately. I really like in this left-hand example that the installer took the time to paint the conduit. Those are the little details that always, show me that this installer is really taking the time to do it right. I do like that they're able to bring down the Sol-Ark into these wiring troughs, and that they didn't just do a 48-inch or a 6-foot wiring trough. They actually, got some wiring gutters that fit just underneath the Sol-Ark as well. On the right-hand side, again, one thing I really like about this is that they put in a bypass so that if they ever need to service the Sol-Ark and the batteries or something happened to the system, they can just clunk clunk and switch over to the grid side and bypass this entire system as well. Also notice what I like is that they installed the battery backup system, or there's probably solar here as well, in the corner of the garage. This looks like a garage door right here, so that they didn't have to install parking bollards. And we do have other classes where we talk a lot about the building and fire codes that are related to these energy storage systems. And one of the big things is these parking bollards, these yellow pillars that you see there. So this system, right, these batteries are probably at the back of the garage where somebody might pull in and crash into them. So they were required to do that. This, I think, looks really nice that we're able to bring in the power. Again, probably, John, what you might be also asking for, and we're on our way, is whether or not you could have the punch outs on both sides of the controller. And on the next gen, we're doing that. And you can see that this installer, it looks like they're still working on it, but they could punch out here, come down into this wiring trough, punch out on the left-hand side of this controller and come down in here. You can see they've routed the battery conductors on the outside here and come into the gutter this way. It is acceptable, because this is 48-volt nominal battery cables, to have exposed conductors like this. But again, a lot of installers, and I always encourage installers to do this, is to put it in conduit. I'm always blown away by how heavy batteries have gotten on the market. And a lot of the batteries have the batteries and the inverters integrated, so they get really heavy. Our batteries are 135 pounds each for each one of those 6.6s, and you can stack them up and then go ahead and secure them to the wall and then put the controller on top. You don't need a lift or anything like that as well. We can scale up to 6 stacks, and that brings us up just under 120 kilowatt hours. I want to take just a moment to talk about the wiring diagram. A lot of times, especially if we're lucky and we have the separated disconnect from the distribution center of the house, we can bring in all of that 200 amps in there. Remember that the Sol-Ark does not have a service rated disconnect inside of it. So you're still going to need a disconnect on the outside of the house that is able to be turned off by the fire department. But you can bring that in, then bring out the 200 amps right down into the main load center of the house. Between the controller and the inverter, you could run battery cable, one red, one black, 4-aught. But if you're going to be running that in Conduit and you look very carefully at the NEC code tables, what we want to see is dual 2-aught. So 2 reds, 2 blacks of 2-aught coming up into that Sol-Ark. And what makes that really nice and easy is that the Sol-Ark does have dual battery inputs. So you just use 2 of them. And what's nice also is that inside the controller, we've made it very easy to double stack the lugs, so you can bring that down in. Communication is key for all of these systems. Software is becoming more and more important. You're going to want to run Cat5e or Cat6 from the controller to the inverter for that closed loop comms. If you do have the EnergyTrak, you're going to want to run the same Ethernet cable from the controller down into the gateway so you can get that monitoring ability. Another key thing to keep in mind, if you're going to be running those Ethernet cables inside the same conduit as power conductors, be sure you get the shielded cable so that they're not getting any crossover talk or interference. Keep in mind, please don't put these energy storage systems, these battery backup systems inside habitable spaces of the home. They're really meant to be garages, basements, outside. A utility closet has the door to the outside. I'm always kind of blown away by, there's a lot of portable energy storage systems, mobile energy storage systems, these power packs that are hitting the market that are scaling up into large capacities, and there's no UL certifications specifically like they have on the 9540 or the NFP 855 that require them to not be installed in habitable space of the home. Let's take a look. It looks like we got another question. How do you, so we're asking, how do you ensure the waterproof performance of your pack, especially for outdoor installations? So one of the things we do, we have IP65 rated, and they, on the top of it, there's seals, and to be able to make sure, and that's another key thing, is when you're making your conduit connections, be sure you do it appropriately so that you are maintaining the waterproof connections from conduit down into the Sol-Ark as well. I think we've also, engineering's probably also, I know they have taken a pressure washer to it and tested this and validated it. So those IP65 ratings, I believe, are third-party certifications that show our batteries are able to be outside. If anybody hasn't attended a Mayfield, Ryan Mayfield, I look up to him in a lot of ways. He runs a great training program, and Ryan Mayfield put this out, and there's the link to it right there. Again, everyone's going to get a link to this, but it just shows we need to be 3 feet from doors and windows, 3 feet apart from the batteries. And then there's certain maximum amount of energy storage system that we can have in certain locations on the home. This varies a little state to state. And in California, we actually can go a little bit more than this. And this is a cumulative amount as well. So you can put 80 on the garage, you can put 80 on the outside, and 40 in the utility closet or the basement for a maximum of 200 kilowatt hours. Out here in California, they raised that actually up to 600, and there's some caveats to that, but keep in mind on this spacing as well. Please don't use the instruction manual as a knee pad. We put a lot of time and effort into making this a very clear and understandable instruction manual. And I can't say the same for all of our competitors. We also have what's known as an integration guide that is kind of a different version of the installation manual, walks it through more like a story. So I'll make sure I send that out to everybody. When you go to install the batteries, You can either do it on the floor or the wall. If you're going to do it on either, you still have to install the wall bracket. And the wall bracket, again, meant for the North American market. Not we have wood stud walls, right? We don't have concrete walls. So we have the spacers on the punch outs on the bracket set for 12, 16, or 24-inch on center studs. Make sure you find the studs, and that allows to the battery to be hung up on the wall. All of the batteries are held together with tabs, and then there's screws that hold that together, not only battery to battery, but also up against the wall brackets. And recently we've gone through UL 9540 edition 3 that required us to pass seismic testing. So these things are very robust, and they're going to hold the battery really securely to the wall. We do have little vanity side covers that cover up the sides of the batteries. And again, this is illustrating that punch out right here. So make sure you get the appropriate conduit fittings. Inside the conduit bay, there's controller bay, positive, a negative. This right-hand side one is going to be going to the inverter. This left-hand side one is going to be going to your EnergyTrak if you have it. And there is an optional grounding lug as well. And this is a nice LB to do it right here. So when you are doing the communication cables, again, out of the right-hand side is our CAN port, and there's no need to redo the crossover or change out the pinouts on your Ethernet cables. It's hard enough for me to do those. You're just going to use this crossover adapter, which is included. And this will allow you to not have to worry about changing over the Ethernet pinouts, and just go ahead and plug it right there into the CAN port on the Sol-Ark. If you're going to have the gateway, again, there's a little adapter that you got to use to make that happen. I think one of the great things is I mentioned earlier that install had 4 stacks of battery, which requires you to use a combiner, that Midnight Solar combiner. Victron makes a great one too. But if you're going to have a Sol-Ark 15K with just 2 stacks, you don't need a combiner. And because, as mentioned earlier, that Sol-Ark has dual battery inputs. Now, if you're going to have a single stack and you decide to use 4-aught, you're going to want to use the little fork adapters so that the Sol-Ark is capable of bringing all 275 amps into the Sol-Ark. Remember, the Sol-Ark only has 200 amp battery breakers, and if you want to go above that 200 to 275, you're going to need to leverage the fork adapters to bring all of that current in on there. EnergyTrak is really easy to set up. Again, it's subscription free, and it allows you to see a lot of the granular level of the batteries. And there's different permissions or different roles that you can set up. One for you, the installer, one for you, your technicians, and then one for the homeowner as well. We're going to kind of get closing out here, and if you have any questions or comments, remember, I want to hear if somebody sells a maintenance plan and what maybe you charge for that for your batteries and solar systems. Sizing and understanding the sizing. And one of the easiest ways to do this is actually leverage some of those tools like Open Solar to plug in all this information. It's going to tell you the backup in there. But if we just break down some of the math, what we did is you take a look at somebody's utility bill and see how many kilowatt hours they use per month. You can then take that utility bill, the kilowatt hours per month, divide by 30. That's going to tell you how many kilowatt hours per day they use. A couple ways to figure out how much power they use. We just had done energy, but you could have homeowners turn on maybe what they expect to use in an outage and just stand next to the electrical meter. If it's one of those digital smart meters on the utility meter, it'll kind of flash through a few screens, and it should tell you what your consumption is, and you get an idea of how many kilowatts a home might use. If you download that interval data, those spreadsheets also will tell you not only energy but power, and so you can sort through that table, figure out how much power they use. But in Schaefer's example, Mike Schaefer, this is one of the guys we work with. He uses 25 kilowatt hours a day, and he uses average power is about 1 kilowatt. So we know a Sol-Ark 15K is easily going to be capable of providing the amount of power to power the home. But let's think a little bit about 25 kilowatt hours a day. So if you used 25 kilowatt hours a day and we installed a 20 kilowatt hour battery, you'd get maybe just a little bit less than 1 day or 24 hours of backup. If we installed two batteries, two stacks of three, so 40 kilowatt hours, you'd get about 48 hours of backup, and that not including the opportunity to charge it up with solar or be able to recharge it with batteries. Keep in mind too that the amount of power people uses varies widely over the year. And again, having that interval data will really give you insight into the homeowner's electrical usage, which can be a great way to educate them on energy saving measures. But we can see, he uses only about 600 watt hours a day in that low period. So he's going to get significantly longer backup periods. And what we can do is maybe recommend a package. Don't give homeowners too many options because they get confused, but we can sell them a Sol-Ark 12K because we know we got 1,000 watts. Maybe he has a couple of surge loads on there. 12K would be perfect. And we'll sell them 16 kilowatt hours of storage. Again, well, no, 13. We can definitely, and then sell them additional batteries and give them that options as well. Again, if you haven't reached out to your lawmakers, please reach out. That 30% tax credit is on the hook right now. That could really devastate our industry, and reach out as well. So that's all I have. Did a little quick today. Again, my name is Daniel Moyer. Energy storage training at basco.com. That's Briggs and Stratton Company.com. Reach out, let me know if you have any questions, and I'll be sure to get everybody the slide deck and the recording. And if you have any questions, go ahead and put that out. And otherwise, I don't see anything. We'll see everybody next time. And thank you again for joining.